Okay, now we are going to study about phase diagram. See, the central theme in material engineering is the property of a material depends upon its underlying microstructure. See, whenever we are studying about a material, we should know the microstructure of that material. So the development of microstructure of the material depends upon its overall composition as well as variables such as temperature and pressure. So as the composition involves more elements, the number of phases that may present increases. So in simple, what can I say? The phase diagrams is nothing but a graphical representation of what phases are present in a material system at various temperature, pressures and composition. To say it more simply, you can see this examples. So if I'm going to study about water, so what are the components present in water? So hydrogen and oxygen are the components present in the water. So what is the phase of that water? So how the water will be looking like? It is in the form of a liquid. So the phase is liquid. So next system what I'm going to study is about water plus ice. So what are all the components present in water and ice? Again the same H2O. So here if you see the phase, it is a combination of liquid plus solid. Next what I'm going to study is about brine. So brine is nothing but a solution of water plus sodium chloride. So it is, if you mix water with sodium chloride, what will happen? It is again a liquid solution where you cannot separate it. So why should we study phase diagram? See, phase diagrams are used by engineers and scientists to understand and predict many aspects of the behavior of the material. So we need to know as an engineer we should know the behavior of the material. So because of that, what we are doing, we are studying about phase diagram. So when we study phase diagram, these are all the questions which we can get. So what condition is the material in it? So it is in whether it is in a liquid phase or it is in a solid phase or it is in a combination of both. Is the composition is uniform throughout? If not, how much of each amount is present? This is nothing but how much amount of a particular material is getting soluble in other material. For example, if I take salt and if I'm mixing it water, there is a particular limit where my salt and water will get mixed up. So what is the portion if I'm mixing what is the portion? That is this question. Is the composition uniform throughout? If not, how much amount of each component is present? Is something present that may gives undesirable properties? What will happen if the temperature is increased or decreased, pressure is changed or composition is varied? So these are all the information, these are the questions which we can get from by studying the phase diagram. The answers for that one is here. You see, to show what phases are present at different composition and temperature under equilibrium condition, to indicate the equilibrium solubility of one element in other. So how much amount of one element will get soluble in the other element, and to show what phases are present at different composition. See at what phases are present at different composition, and to indicate the temperature range over which solidification of a material takes place. At what temperature the solidification of the material is going to take place, and to indicate the temperature at which different phases starts to melt. So at what is the temperature at which the different materials is going to start melting. So these are all the informations what we can get from the phase diagram. So what are all the terminologies used in phase diagram? So component, if we are studying about copper and zinc, if you are studying about copper, zinc, brass, the components are copper and zinc. So system, copper, zinc is the system. Right? A system having one component is called unary system, and the system having 2, 3 and 4 components are known as binary, tertiary and quaternary system. If the component is having only one particular compound, then it is called as unary component. If for example, if we are studying about in this example what we are studying about copper, zinc, brass. So here how many components are there? We are having 2 components. So this is called as binary component system. Mostly in this subject we are going to see about binary component system. Okay, so you know what is an alloy? An alloy is a combination of 2 or more metals is called as an alloy. So what is the meaning of solid solution? We have seen previously. So solute is a smaller portion in the solvent is what we called as a solute. So solvent, the major portion of the material is called as a solvent. So what is the meaning of a phase? a phase may be defined as a homogeneous portion of a system that has uniform physical and chemical properties for having. So here they have given what is the meaning of term phase. A phase is defined as any physical, distinct, homogeneous and mechanically separable portion of the system, right? So again, what I can say, a phase is nothing but a single system, right? If I add salt with water, that is a single phase system where I cannot separate the salt from the water. Or else what I can say, water is also a single phase system where you cannot separate the hydrogen in the hydrogen and oxygen from that water. So next is equilibrium. So equilibrium is said to exist when enough time is allowed for all the possible reactions to complete. I'm giving enough and suitable time for all the reactions to complete. That is called as equilibrium. Solubility limit. So it is the maximum concentration of solute that may be added without forming a new phase. See, solubility limit is, for example, if I take 100 a glass of water, if I am adding some amount of salt, it gets mixed up well. If I am adding more and more, so at a particular point my salt and water gets dissolved. If I am adding more amount of salt, what will happen? It will not get dissolved. So up to a limit where the salt is getting mixed is called as solubility limit. And degrees of freedom is nothing but the variables such as temperature, pressure and composition that can be changed independently without changing the phase or phase of the system. So degrees of freedom is nothing but number of independent variables, such as if I vary temperature, I can vary temperature, pressure or composition, okay, that can be changed without changing the phase or phase of the system. So I can alter my temperature, pressure or composition such that my phase of the system should not get changed. So that is the degrees of freedom. So what is meant by phase? We have seen it clearly. Yes. So here comes a phase diagram of a pure substance. That is nothing but one component phase diagram. See here, this is a phase diagram for one component system. That is nothing but one component system is nothing but water is a one component system where it does not have any other components. So this point is called as a triple point where water. So we know that water exists in three forms. What are those three forms? Solid, liquid and vapor. So this is a triple point. So this line is called as freezing line and this line is called as vaporization line. So as at 1 atmospheric pressure, if you go and see at 100 degrees Celsius, this is a boiling point. If you increase the temperature further, what will happen? Your water will be converted into vapor. Here this is a point where your water will be in the form of ice. So this line is called as a freezing line and this line is called as a vaporization line. This is called as a two-phase line because here you are having a solid phase and here you are having a liquid phase. So this line is called as a two-phase line. So again, this line is also called as a two-phase line because one side you are having a liquid and the other side is you are having a vaporization. See, so using this phase diagram, what we can do is at a particular pressure and a particular temperature, what is a condition of the water molecule we can study. So this is about phase diagram.